I've already shown all my working out here, as you can see, so I'll just talk you through it. We've got the curve described by the parametric equations x and y. We're told the point P has got a value of theta as pi over 6, and we want the equation of the normal. So I'm thinking y equals mx plus c, and I'm thinking negative reciprocal for the normal. So to differentiate, to get my gradient, here I've differentiated the x function in blue. When I'm differentiating the 1, that's going to disappear. Now I know that cos differentiates to minus sine. So when I've got a minus cos, like I do here, that's going to differentiate to plus sine. So that's why the minus has disappeared. And then by the chain rule, I've remembered to times by 2 as well. So that's why I've got 2 lots of the positive sine 2 theta. Then I'm going to differentiate the y function. I know that sine differentiates to be cos. And then again, I need to remember to times by the 2 because of the chain rule. So that's why I have 2 lots of the cos 2 theta. Now I'm going to use the equation for the gradient when we have parametric curves. So I'm going to substitute the dy by d theta in here, and I'm going to substitute the dx by d theta in here. So I've got the red 2 cos 2 theta divided by the blue 2 sine 2 theta. And we can see now that the 2's are going to cancel out to leave me with just cos 2 theta over sine 2 theta. And at that point, I've substituted the pi over 6 in instead of the theta. When you do this, make sure that you have brackets around the 2 theta. If you don't do that, you will get the wrong answer on your calculator, because we need to make sure that we do 2 lots of the pi over 6 first, and then do cos to that. Same for the sine. We need to do 2 lots of the pi over 6, which gives us pi over 3, and then do sine of pi over 3. So make sure you have brackets around the 2 lots of the pi over 6 on your calculator. So that gives us that the gradient of the curve at that point is root 3 over 3, which means that the gradient of the normal at that point will be the negative reciprocal. So it will be minus 3 over root 3. So just doing the reciprocal here and making it negative. This is a bit awkward though, so I'm just going to rationalise that. So times the top and the bottom by root 3, which gives minus 3 root 3 over 3. We can then see the 3's will cancel out to leave a gradient of minus root 3. I'm then going to do y equals mx plus c. And then we need to work out the coordinate of the point P, because that's where the normal goes through. I know at point P, theta is pi over 6, so I have plugged that in here to work out what the x coordinate is. So 1 minus cos 2 lots of the pi over 6 is a half. So the x coordinate is 1/2 when theta is pi over 6. And then I've substituted the pi over 6 in here to work out the y coordinate. So sine of 2 lots of pi over 6 is root 3 over 2. So that's why I've plugged the root 3 over 2 in here, and I've plugged the 1/2 in here. The minus root 3 times a half is minus root 3 over 2. I've then added that to the left-hand side to work out c. Root 3 over 2 plus root 3 over 2 is root 3. So my y-intercept is root 3, and then I've just added the minus root 3x. I've added root 3x to both sides to get the answer in the form that the question asked for.